There are two types of graphs that we might want to look at with the binomial distribution. The first one is the binomial distribution itself. And the second one is the cumulative binomial distribution. Now, we'll have a look at this first one, the binomial distribution. It's worth keeping in mind that you will find a graph that will have the y-axis will be the probability. Look at how neat that is. And the x-axis will be the number of outcomes that you're looking for, up to the total of n trials. So if I had a system where I might have 7 trials, then I'm going to have 7 points and a 0. And it'll be made of dots. So you might have a binomial distribution graph that looks something like this. And this one shows you that the probability of having 0 outcomes out of 7 is this point. The probability of 1 outcome is this. 2 outcomes out of 7 is here. And so on for 3, 4, 5, 6, 7. Now there are a couple of things that are worth noting, and this is what matters in the graph. First of all, my mean, my expected value, equals NP. So for example, if I tossed a coin 10 times, then my expected value of heads would be half of those, and therefore 5. In this system, I've made a system where n equals 7, and it looks like the mean is around 2, or somewhere between 2 and 3, which means P will be somewhere between 2/7 to 3/7. And that's how the mean will be up here. So the peak indicates to us where the approximate mean is. You'll also notice here that the peaks are near 2, and we have what's called a positively skewed graph, which means it has points and the tail moves to the positive direction. This also implies, because it's positively skewed and it looks like that, for example, that P is less than a half. If P was greater than a half, it would look like that. If P equals a half, it's going to be symmetrical. So it might look more like a standard bell curve. And they're the general shapes that you'd expect from the binomial distribution. They're the things that are the most important to us. Remember, the peak is where the mean is, but our points are only at integer values on the x-axis. And if my probability of success is less than a half, then you can expect the peak to be on the left side of the graph. If the probability of the desired outcome is more than a half, you'd expect the peak to be on the right-hand side of the graph. And if the probability of our desired outcome is 1/2, you will expect a symmetrical graph with the peak in the middle of the graph. And finally, each of these points here, so here I have an x value of 2, that's the probability that x equals 2. And this level here is the probability that x equals 3, and so on. So we could read from the graph what the probability of each number of outcomes in those trials is. The graph of the cumulative binomial distribution is slightly different in that even though we have a probability on the y-axis and x on the x-axis adding up to our number of trials, and let's imagine we're going with the same system where we have 7 trials, the cumulative binomial distribution actually tells us what's the probability that x is less than or equal to the value we look at. So our value of 0 was here. And in the previous one, our value of 1 was here, and our value of 2 was up here. The cumulative graph will add this point on to the original value. So when 0 might still be in the same spot, or it will be, 1 will be 0 plus 1, which will be up here. And 2 will be 0 plus 1 plus 2, which will be up here. So then our points here is the probability that it is less than or equal to 1. And this y value will be the probability that it's less than or equal to 2, and so on and so on. And in that way, the cumulative binomial distribution graph will actually look more like this. And it will approach 1 on the probability, because by the time I get to the last point, the probability that x is less than or equal to n is every single possible outcome in the system, and that will equal 1. Most of the questions you're asked in Maths Methods will ask you about the binomial distribution graph and not the cumulative binomial distribution graph. So let's do a quick summary of the binomial distribution graph. So remember, point number 1, the peak is the point closest to the expected value or the mean, which is calculated by NP. Remember, if my probability is less than a half, I'm going to have a positively skewed graph. And that will look something like that. If P is greater than a half, the probability of success, then I'm going to have a negatively skewed graph. And that's going to look more like that. And if P equals a half, I'm going to have a symmetrical graph. And the peak is going to be halfway between 0 and n. So it will probably look something like that. And finally, remember that I only have points where my integer values of x lie, which means these graphs actually aren't perfectly correct. And there should only be points on the integer values. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.